So graphing trig functions is just like graphing any xy function. The only difference is your x-axis is going to be an angle you choose, and the y-axis is going to be that trig value evaluated at that angle. So for comparison values, right, if I have my basic sine curve here, it may look like just random points and a random curve, but it all makes sense, right? At pi over 2, I have sine is equal to 1, the output. On my unit circle, at pi over 2, my y value is 1, and y value is the same thing as sine. And that's really all that is to it. It's just a continuation of this pattern, but on a xy coordinate system. Some things to note. Generally speaking, when we have just y is equal to sine of x, no change or anything, our quarter points are 0, pi over 2, pi, 3 pi over 2, and 2 pi. And my output is going to be at sine of 0 is 0, sine of pi over 2 is 1. You get the idea. This is going to be a general function of a typical trig outline. The main takeaway is that period is equal to 2 pi over b right here, and the phase change is c over b. Now this will all make sense in the first example that you'll see. Just hang in there. So for this first example, y is equal to 1/2 sine of x minus pi over 3. I'm first going to look at my phase change right here, c and b. So b is 1 because there was a 1 in front of that x, invisibly speaking, and c is positive pi over 3 because remember, from our formula here, it's negative c, and we're going to take that positive value over here. So my phase change is c over b, or just simply pi over 3, and that means for all of my initial theta values, I'm going to add pi over 3 to those values. So instead of having 0 as my first x, I'm going to have pi over 3. And my next value would be pi over 2 plus pi over 3, and I do that for the rest of them. I guess something like looks like this. All I did was just add pi over 3 to these values here. That's it. Now to get my output, my height of my graph, I'm going to multiply this coefficient by all the typical y values. So 1/2 times 0 is still 0. 1/2 times 1 is 1/2. You get the idea. These are my new updated y coordinates. So when I graph them, I should get something that looks roughly like this, more or less, but you get the idea. Next example. This time I have a negative out front and have this weird looking fraction. It's still the same thing. b is equal to 2 pi over 3. c, on the other hand, there is no c value, so it's just equal to 0. So my phase change 0 over anything, it's still going to be 0. But we're still going to look at our period. Now remember, here, period is 2 pi over b. That's going to affect how long or short my graph is. So, again, 2 pi over b, b is equal to what we found over here, a fraction divided by fraction, etc. 2 pi's cancel out, that's algebra, we get 3. So my interval goes from 0 to 3. And to find my new quarter points, I simply subtract 3 from 0 and divide by 4. So my increments are going to be 3/4. That's how much I'm going to increment for my new points. My final points are therefore going to be 0, 3/4 plus another 3/4 because that's my increment plus another 3/4. That's all it is. I updated these values to these values. Finally, my y, as you might have guessed, you multiply by this coefficient 2 here. It's an absolute value. That just tells me my altitude or aptitude. You get the idea. My y values are therefore updated to be 0, -2, 0, +2, 0.